Chromatic aberration. What is it? Why does it happen? And how can we fix it? But first, let me tell you a story. It was the summer of 2015 when I really got interested in astronomy. I wanted to learn all that I could about it. In fact, I even got my hands on this, a beautiful machine which boosted me into a journey of exploration and wonder at the beauty of the night sky. I saw how breathtaking it was to see planets, stars, and even a galaxy far, far away. This was one of my first attempts at afocal astrophotography. That's a fancy name for taking pictures of space, and yes, this is Saturn. You can even see the rings on it. I literally pointed the telescope at Saturn, put my mom's smartphone into the telescope eyepiece, and took a picture. Here are two images. Both are of Saturn. Of course, the higher quality one is from NASA, and the other one I took through the telescope. Notice anything odd about the picture I took? What are those? On the left, there's a blue fringe, and on the right, there's a red fringe. But why? Upon some research and asking on forums, I eventually discovered that this interesting scientific phenomenon is called chromatic aberration. It's a tricky concept that I vaguely remember learning in science class in physics with a ray diagram that looked kind of like this, with a convex lens in the middle, and we have light that refracts, that is bends through the lens and comes to meet at a focal point. That's where all the light rays come together. However, different colors actually refract in different ways, and exactly why? That's a topic for another video, but what you need to know is that blue light bends the most and that red light bends the least. So there are actually multiple focal lengths. And this is, of course, an exaggeration. It's not that drastic. But what I think is kind of weird is that this is a side view of what's going on. It's like a cross-sectional. But I don't think that's how it should be displayed. And I think it makes more sense to use a bird's eye view. Anyways, at first and for quite a while, I even gave up on trying to understand what chromatic aberration was. But I eventually saw it more and more, and it continued to fascinate me. I needed to get to the bottom of this. What is chromatic aberration, and why does it happen? After lots of time and effort, trial and error, I think I finally understand. Let me explain to you what I did in the simplest way I can. We like to categorize stuff. The concept of chromatic aberration goes under the umbrella of science, more specifically in physics, and within that, optics. Chromatic aberration is a lens defect. Essentially, it happens more with lower quality lenses. To a degree, it happens with any lens, including tablets, phone camera, magnifying glass, glasses. For this experiment, we're going to be looking at what a focal point is, and that's when you have a large light source and the light rays come together and hit a focal point in one point, and you're going to be seeing that through this exercise. And you can even try it at home. All you need is a magnifying glass and a flashlight. Here we have a magnifying glass and a lamp, and if we tilt the left side towards us, chromatic aberration actually happens. You see, the blue is on the right and the red is on the left. However, if we tilt the magnifying glass so that the right-hand side is towards us, it actually flips. And we see that blue is on the left, whereas red is on the right. And so if we keep tilting it, it actually flips. So now we're going to draw that from a bird's eye point of view. We're going to translate that experiment into a simple diagram. It's from a bird's eye top view. Here is the black lampstand. This is the convex lens magnifying glass. Remember we said that the left side of the magnifying glass was towards us, that the lamp was red on the left and blue on the right? Here's light as it travels through the magnifying glass and it bends to go through the focal point where the ray touches the dotted line. Remember how we discussed that blue light bends more and that red light bends less? Here's where your eye would be. It would actually be the camera. I'm shading the image that we see. The red matches up, and so does the blue. Now, let's take a look when the magnifying glass was tilted the other way, with the right side tilted towards us. There's the lamp and the lens. Light bends again. This time chromatic aberration was flipped, with red on the right and blue on the left. Blue light bends more, whereas red light bends less. They actually have different focal points, so the image isn't perfect. Here's the eye, or the camera, and this is how the image is formed. We see again that the blue fringes match up, and so do the red fringes. So, how do we fix chromatic aberration? Scientists use what is called an achromatic lens, which is a doublet of two different lenses that have chromatic aberration in opposite directions, and it cancels each other out. Here we see light pass through. Blue light bends more through the convex lens, but bends less through the concave lens, so the effect cancels each other out. And the opposite happens for red. They all come together at the focal point, and our eye sees the image with no chromatic aberration. This is revolutionary in the field of optics, and achromatic lenses are used in telescopes, microscopes, and cameras.